Well, good afternoon, everybody. Welcome to this Crane Commercial Service CCS hosted webinar today, which covers the effects of hand arm vibration in the workplace, delivered by Southern Power Tools. For those of you who don't know me, I'm Steve Carman. I'm commercial lead in the construction category at Crane Commercial Service. Good afternoon. Pleased to introduce what I hope you'll find a very interesting session learning more about hand arm vibration. Delivering the webinar for us today, we've got Drew Bartlett and Richard Hyde representing Southern Power Tools, who you may be aware are one of the many key contractors that we have working on our CCS public sector frameworks. So with millions of operatives throughout the UK at risk every day due to hand arm vibration, HAV, we've invited Southern Power Tools, one of the suppliers on our buildings, materials and equipment framework, to talk about the effects of this important topic and how this could be managed and mitigated in the workplace. This gives you the unique opportunity to hear from an expert contractor with the experience within this field in the construction industry. So to that end, my hope for today is that you'll come away with some fresh knowledge of the effects of HAV, and I really hope you enjoy the session. Please feel free to add any questions that you might have. You should see an area on your screen for questions to allow you to type that in. We'll have a Q&A session if there are any questions at the end of the presentation. Schedule for today is around 30-minute presentation, followed by a bit of time to answer some questions if there are any noted down. So without further delay, I'm going to hand you over to Richard and Drew now, who will begin the webinar. I hope you all enjoy it. Over to you guys, Drew and Richard.
Lovely, thanks for that, Steve. Appreciate it. Good afternoon, all. First of all, I'd like to thank you for taking time out of your busy schedules to learn more about the hugely exciting world of hand and arm vibration. Not a subject that you know we're all completely up to speed with, but this is exactly the purpose of today's webinar, to give you some more knowledge on it. Although it might not be hugely exciting, it's hugely important within all the industries. So my name's Drew Bartlett. As Steve has just said, I'm one of the directors of Southern Power Tools. We're a family-run business started by my dad, Peter Bartlett, back in 1980. So we're nearly 45 years within the industry. He's still very much on board, and we're basically a highly accredited specialist supplier of all types of tooling to the large industry sectors within the UK. So we deal from the Highlands of Scotland down to the Isle of Wight, and we have contracts covering that whole area. So the sectors that we mainly look after are housing associations, local authorities, government departments, MOD, utilities, and alike. So people or businesses that have a large workforce out there in the workplace who are supplying tooling, and our job and our expertise is we offer a complete service framework which covers the whole supply of and compliance of power tools and hand tools within that industry. So we take that burden away from you, basically. So today we are concentrating on hand and arm vibration. I will be handing over to the highly knowledgeable Richard Hyde in a second. Richard is our trainer, our HAV management professional. He's been working with us for several years now. I think it's been up about 5-6 years we've been working together. So the webinar is basically going to cover how it occurs, what effects there are, how the legislation and regulations and controlling HAV and what is required from an employee's point of view. So this is all aimed at making sure that your workforce are, first of all, just kept safe and making sure that there are no long-term effects working for you. So without further ado, I'm going to pass you over to Richard. As Steve said a minute ago, we've got about a 30-minute presentation, and then we'll be following that up with any Q&A that you've got afterwards. And then, yeah, we'd like to engage with you more further on after that. So, Richard, if you're ready, I'm going to be controlling, so it's going to be very much next slide, please, kind of situation. So bear with us on that. But, yeah, I shall pass you over to Richard.
Hi everybody. I probably won't say next slide. I'll probably say just Drew each time. So forgive us for if you get fed up with that name after a while. It's just some IT issues. I want to talk about vibration, really what it is and how it affects us. Maybe some control measures we can all put in. Things what you as an employer can do, things what the manufacturers of the tooling can do on that, but mainly what the operator can do as well. So we've all developed as a species on that. And at the same time, our hands have developed as well, from things like paws to something very similar to what we've got today. You know, we've got hands which we can move around quite easily. We've got opposable thumbs, which makes our hands quite successful for using tools. Things change. Drew, the next slide, please. If you want to click through the next two and the next one again. Things changed about a few hundred years ago when we stopped working in fields. We stopped being hunters and gatherers, working in small jobs, and we started using heavy machinery. And not just heavy machinery which vibrates in our hands. Now, at this point, our bodies haven't developed sufficiently to handle that vibration. So we've got to have limits of how much vibration we can use to stay safe. Drew, please. Now, what vibration does to us, it affects our hands. But when we talk about hands, we talk about hands and our arms right up to our shoulders. Drew, can you click the next few, please? To the end of this slide. So what it does, and one more, what vibration does, it affects our tendons, and that affects how you hold things. It affects the muscles in your arms which control the tendons, so that affects the strength of grip. It affects your bones and joints, and it can affect your nervous system. Next slide, please, Drew. So it damages our blood vessels. We're all aware of white finger. Now, white finger is quite extreme. You know, but there's other issues what vibration can bring on as well. But white finger used to be very, very common, but not so prevalent these days as what it used to be. But it's still a big issue on that. And next, please, Drew. What white finger also does, it damages our nerves. Now, we're not talking about making you a nervous type of person, but it affects how we feel things. You know, your brain is talking to your body all the time. You know, if you want to pick something up off the floor or touch something, the ends of your fingers are telling your brain that how hot it is, what texture it is, all sorts of signals. What vibration can do, it can damage that signal which goes to your brain. And you've got to think, that's how our hands all work. Drew, please. Now, it only needs one of those things to go wrong. Can you click through, Drew, on that? I'm very passionate about vibration in lots of ways. I've gone just a bit too far. We'll stop at that one. I'm very passionate about vibration in a way because it affected me personally. You know, many years ago I was using tooling, and now I've got arthritis in my shoulders. I've got problems in the joints around there from using tools many years ago, which are far more heavy than what they are now. But it's not just a physical thing. It can be a mental thing. You know, people with issues with vibration, you know, if you can't use your hands, you can't work, you're in pain all the time, it can affect your life. Not just your working life, it's affecting when you retire for many years to come. You know, if you can't do things, if you can't get yourself dressed in the morning, you know, you can't hold things properly, somebody has to feed you. That affects people, their mental state quite severely. Drew, please. So the sort of effects we have pains to our issues with pain in our circulation, how the blood's flowing around, affects the ends of your fingers. We get pins and needles. You have people almost screaming in pain at the end of the evening when the blood's trying to get back into their hands. We get the white finger. We also get ganglion cysts appear, but we also lose the strength in our hands. Drew, please. But we don't know how long this is going to take. It's just like smoking. You know, some people smoke and they get cancer. Some people smoke and they don't get cancer. Our bodies are all different. So we can't say that X amount of vibration is going to affect everybody the same way. It affects us all differently as it goes through. Drew, please. So there's lots of risk factors involved in this. Now, I guess you're all pretty aware of most of them on these ones, but if you want to click Drew, the first risk basically is you're an individual. You know, some become hereditary through your family on there. It could be your lifestyle. All different things could affect things. The next thing is how much vibration that tool exhibits. When we buy tools, do we actually look at what vibration that tool has, or do we just look at price or the model or if we have batteries for that tool already. But really, the vibration is one thing, but it's also about trigger time. How long can you use the tool for? If you're only using it for short periods, does it matter if it vibrates a lot? But if it's for longer periods, yes, it does. It's your body positions. If you're using a tool with your hands above your head, how can the blood flow to your hands at that point? It could be how tight you're holding the tool. We'll get back to that in a moment. But it's also when your hands are wet or cold, things like that. So if you've got people working outside, do we supply gloves to them? Are the gloves dry? Things like that. Drew, please. Okay, our hands are very complicated, aren't they? When you look at you abuse your hands every day like we all do. It's just there. It's a tool we use. But when you think about it, 29 types of bone in there. Every bone's got a joint. Some joints are like hinges. Some joints are just to hold the bits together on there. Hundreds of ligaments, lots of nerves, all these bits all in there. Only needs one part of that to go wrong for your hand to stop working properly. And vibration can do that to you. Drew, please. So typically that's what white finger looks like. It can be on one finger, it could be all the fingers, it could be all the way down. It varies on different people. Drew, please. So when you've got a healthy hand, your blood's flowing around your body quite freely. It's your heart's beating, it's circulating around your body. The blood's going to the tips of your ears, the toes, the ends of your fingers on there. And it's working quite well on there. Drew, please. Now, we've all got fingers. Now, our fingers have been developed in a way that the top of the hand protects what's below. And below the finger, if you want to click the link again, Drew, below the bone on the inside is where we've got nerve endings, we've got veins, we've got tendons, all in there protected so we don't knock them. Drew, if you want to click the next slide. When we grip a handle of a tool or grip any tool, the bone then in the finger is squeezing against the handle. Now, squeezing the handle then is going to affect what's down between there. So you've got your veins, your nerves, your tendons on there. So the tighter we squeeze the handle, the more pressure we put in on these things. Drew, please. So when you turn the machine on, when you're gripping the handle, that handle is going to bounce up and down against the bone many times per second. If you want to click it twice, Drew. So by beating up and down constantly, by holding the tool while that vibration is happening, the bone's bouncing up and down against the handle, which in turn is squeezing, trapping the bits between there. And that can have effect over a long period of time on that. It can affect how the vein works. It can affect how the tendons and the nerve endings are. Drew, please. So we said that looks like a healthy hand. When we're holding tools for a long time and using them, what happens is this, Drew, please. Eventually, the arteries can actually, or the vein itself can start to constrict. Now that could be a total blockage, but more generally, it's a reduced flow at that point on that. And once it started to collapse, that's it. That's what you've got at that point. So the blood's trying to get into that narrow area. Drew, please. And then we get a thing like that at the bottom. They're known quite by a lot of people as rainbow hands. Basically, the blood is trying to get into the fingers and can't, or it's very difficult to get through. And I always think it's like you're going down the motorway, it's like 4 lanes, and all of a sudden 3 lanes close, so it's 1 lane. All that traffic's trying to get in that 1 lane. You've got it all backing up on itself. And by doing that, that's a lot of pain going into the hands on that. And it's just not just that one day, it could be for your lifetime at that point, isn't it? Drew, please. So what's it like? Early stages, generally tips of your fingers, right at the end, quite often on the one next to your thumb at that point there. Not always, but generally. That's the point where we want people to go to see the doctors or speak to occupational health to try and sort it out at that point. We can't improve that. We could just arrest it at that point. If you don't do anything to that point, it just gets worse. Drew, if you want to click again, please. Drew, can you click again, please? Yeah. So what happens then, it starts spreading down to the fingers. Down one finger, down to further fingers at that point. If you don't think about it at that point, it just gets worse again. So Drew, please Click again. And what can happen then is your fingers begin to swell up and curl over. You basically can't use your hands anymore at that point. Your life changes at that point then, because it's not just working life, it's your personal life. Everything changes. And on your working life, if you can't work, how do you earn money? You know, how do you survive? So it becomes a real issue. And if you don't do anything to that point, Drew, if you can click again, please. It's when gangrene can set in if the blood can't get down there. Now that's really extreme, but it is a possibility. Drew, next slide, please. So we know about white finger on there. That's the one people all talk about. But there's other things which the risk increases by using tools that vibrate. Drew, please. So carpal tunnel. No, carpal tunnel isn't a HAVS injury as such, but vibrating tools are quite a contributory factor, especially if your wrist is moving around a lot. Drew, please. Raynaud's phenomenon. Now, Raynaud's isn't a HAVS injury, but it displays very similar on there with the white finger. Now, what we know about Raynaud's is if it runs in your family and you've got it, you're more susceptible. So anybody who's got Raynaud's in their family should be telling their health professionals in their business that they've got it, so we can actually start reducing their trigger time on tools. Drew, please. Trigger finger, another issue where we get swelling of the tendons, so the fingers pull back on there. Drew, please. Tennis elbow, golf elbow, big issues in there. Drew again, please. And we get the shoulder injuries, tendon tears, but more often the bursa, swelling up. And it's a little bit there like sciatica, where you've got the damage is in one place, but it displays elsewhere. So you can have pains in your fingers and all sorts of places there. Drew, please. Now, we're all very interested in this as well, because there's lots of legislation around vibration. Drew, please. Now, we're all aware also of riddles on there. You report all your injuries and dangerous occurrences. Drew, please. Now, all riddles have to be investigated by the HSE for HAVS. So that makes it quite an issue for people having the HSE on site. Comes a cost, time spent on this as well. Drew, please. Now, the law changed for vibration back in 2005 on there. Now, in 2006, the first fines came out, and it was £10,000 with 28,000 costs involved. So relatively low, but we're talking about 20 years ago now. Drew, please. More recent fines have been around the £500,000 plus costs. Now your costs can be at least double that amount, if not more, on that. And that starts to have an effect on a business at that point. Drew, please. Now, I don't know about your businesses, but a lot of businesses, that's a lot of money they've got to suddenly find. If it's £1 million, where do they find that money? Well, quite often it affects everybody then. It's not just the person who's had the injury, it's everybody on site. So we want to get these things early so we don't get to the stage where it's going to affect everybody on site through spending cuts, wage freezes, and etc. Next slide, please, Drew. So we said this all came out in 2005, the regulations. And at the time, they gave us two values what we work to. We've got action and limit values on there. So next slide, please, Drew. So next one again, please. Now, I always think with health and safety, like a lot of people, as traffic lights on there. So green would be 2.5 meters squared. So that's 2.5 meters of vibration in an 8-hour period. Now, to a lot of people, that doesn't really mean a lot. It's just a figure on there. So hopefully it'll mean something a bit later on today. So next slide, please, Drew. Now, the government wants us to work in the green, the 2.5 meters squared, but in some cases we can work above that. We can go right to the limit value on there, which would be amber. Next slide, please, Drew. And the top value is obviously the exposure limit, and that is a limit of 5 meters squared over an 8-hour period. And next slide, please, Drew. And again, please. So we've got two figures there. We've got action value and we've got limit value on there. Now, the action value isn't a limit. A lot of people do work it as a limit, and that's not a bad place to be if you can get there, because you're well within the, what we're talking about, the safe areas to work on there. But you are allowed to go above that to a maximum of the limit value, which is 5 meters squared. Again, please, Drew. On that, you might click next 3 or 4, one next, and one more, and one more. So when to explain that a bit, it's if you think like a tool, if it's say 4.5 meters squared, it doesn't mean we can't use it. We've just got to limit the time we can use that tool. So we've got here a pneumatic hacksaw going 10.39 meters squared. That means if we stay in the green, we can use it for 28 minutes, and just within the limit value is 1 hour 51 on that. So we need to then work out how long people are using the tools for, and that's probably more difficult than working out what the vibration is, because that varies on a different person on a different day. And next slide, please, Drew. So the government realised at the time that, well, HSE realised that it's very difficult for workers to work out their day on meters per second squared. So they brought out a point system. So to control it, we work on the point system. So next slide, next please, Drew. So 2.5 meters squared, the action value is 100 points. So we really want people to work within 100 points of vibration a day. And next slide, please, Drew. To a maximum of 400 points, which is 5 meters squared. Now, if they're working within those values, though, between the action value, limit value, we've got to have occupational health in place. We've got to be actively looking to reduce the vibration, looking for new methods, reducing or eliminating. And next slide, please, Drew. So we have the ready reckoner table is a well-known route of trying to calculate points per day. Next slide, please, Drew. So when we look at the table, along the vertical column, it's vibration magnitude on there, and that's the meters per second squared the tool's exhibiting. Along the horizontal bar is trigger time, how long they're using that tool for that day. So if you want to click it a couple of times, Drew. So we've got those two. So we've got magnitude and time. You want to click again, please. Now we want people to work within the green on that, work below 100 points. So if we're in that position, happy days, we're all great. So you want to click again, please, Drew. Now, amber, caution really, so you want to click again, please, Drew. Now within that, we can work there. We don't really want to be in that position working at that point, but as long as we've got health surveillance and we are looking to reduce it on there, we are allowed to, because it's still below 400 points. Do you want to click then, please, Drew? What we can't work in is red. We've exceeded the point, so click again, please. For example, we've got an angle grinder going 2 meters squared. We can use it for 6 hours. So all we do is come horizontally from 2 to 6 hours. So do you want to click, please, Drew? So 48 points, so well within the actual figure on that. If you want to go again, please. So this one again, so we've got electric sander now going 5 meters. We can use it for 5 hours. You can click that, please, Drew. 250 points. So we can use that. But should we be satisfied at that? That's the point that, yes, we are okay as far as below 400 points, but we should still be looking to reduce that figure. How can we reduce that figure? So we can look at tooling, methods, how we're doing the job, how the operator's actually using the tool, the setup around that. Is he competent? Is he using it correctly? Is he using a sharp consumable? All those things need to be considered. Please again, Drew. So it's all very well if you're using one tool, because that's a nice and easy way of calculating things. But in reality, people use more than one tool. Some people might use 10 tools in a day. Now, you could sit with that chart and calculate it quite easily. But it's time consuming, isn't it? If you want to click again, please, Drew. But the HSE have made it easy for us. On their site, you know, we can actually we can either download this, it's a spreadsheet on there. So I'm going to click again, please, Drew. We can either use drop-down boxes, and they'll tell you by types of tool areas like a drill is going to be 7 to 13 meters squared, or we can actually type the information in. So you want to click again, please. If we'd worked out the figures, what that machine was, so that drill 6.13, the polisher's 1.34, it's telling us how long to get there in action and limit values, how many points it takes. If you go again, please, Drew. Then if we put in how long we've used the tool for that day, in minutes and hours on there, and click one more time, please, Drew, it can then tell us what our exposure's been for that day. So using that figure, if we know how long the tool's been being used, we know our figures, we can calculate it. Now, if say that figure was, instead of 2.4, that was, I don't know, 4.4, we could probably then look down the list and say, well, which tool's gives the highest vibration? In that case, it'd be the grinder. Could we look at a different grinder for the job? Or we could look the other way, is what tool we're using the longest for, like the polisher. Could we find a way of doing that job a bit quicker on there? Or we could look at all those different things to reduce it down. But using this chart, we can actually calculate our figures quite easily. If you want to go again, please, Drew. So we've been talking about action values and limit values. We've still got to be cautious. If you want to go again, please, Drew. Even working below the action value, in 10 years, 1 in 10 people are going to, on average, start having issues with halves, because some people are more susceptible. We're not born knowing what limit we've got. If you want to go again, please, Drew. And then if you're working to the 400 points, that brings down to 1 in 10 within 6 years. So we need to be cautious about these figures on that. 2.5 is a figure, but it's not the only figure we need to work for. We need to be, if we can, reduce even further at that point. Please again, Drew. So how we control it on there, please again. So what the regulations state on this, the employer has to assess, control, inform, train, check and monitor. That's basically what it's saying on these things, isn't it? Yes, again, please, Drew. So what controls could be good for doing this? Please again on there. So we always go back one, please. We always go look at the hierarchy of control. We're all aware of that, I guess. And first thing people always look at is PPE. Well, PPE is last line of defense, isn't it? It's the easiest thing we can do on there. But is there any kind of PPE what's going to help us with vibration? If you want to go again, please, Drew. So, and again, one more time. Anti-vibration gloves, people talk about them all the time, but do the work? Well, people say it takes vibration out, but in reality, they're quite a dangerous tool. We'd never recommend using them. It's not really particularly effective on low frequency vibration. It does mean you're gripping the tool tighter as well, which can have another negative effect on the whole system. So we'd never recommend using anti-vibration gloves, but they do keep your hands warm. That's the main thing, but all gloves do that. If you go again, please, Drew. On that, that's just what I've already said, basically. It's not very good at different frequency weighted vibration. Again, please. On that, and one more time. So the next thing is admin controls. Can we look at different ways? Train people how to use the tools differently. Can we get a maintenance scheme in to get the tools right, checked on a regular basis, rather than wait till they break down? Can we limit how long people use tools for, or can they share that job? Another one, please, Drew. Then could we look at engineering controls? Could we isolate the worker? Sometimes, not always, but you can sometimes. If you want to go again, please, Drew. So if you think the old breakers, breakers are good tools, but very, very high in vibration. If we get somebody sitting in a cabin behind one working the tool, it's not always applicable. Small jobs maybe not, but sometimes it is. Again, please, Drew. And then substitution. Can we replace the tools? Are we buying the best tools for the job? Are we buying the cheapest, or are we buying tools we've always bought? Have we looked at these things on that? Do we really know what vibration the tools exhibit on that? Next one, please, Drew. So looking at that, the guy's holding a power drill, two-handed, going into the steel. If you want to go again, Drew. Could we use a magnetic drill instead? Is there another method for doing the same job where his hands are completely away from the operation? Which all depends really on how many times you're doing this. Is it reasonably practical? But it needs to be considered. Please again, Drew. And the most effective method we can have is elimination. It's the hardest thing we can do, but it's the most effective. Not the easiest thing to do. John, go again, please, Drew. Looking at different ways. Do we really need to do a job? I was working with a foundry where they were fettling all of their parts. The agreement came down after a while because it was very high vibration. They were only going to fettle the parts where there was a joint going forward. The parts weren't viewed elsewhere, so did it matter it wasn't fettled? And it's just looking to see if we really need to do that in the first place, what we're doing. Please again, Drew. So that's the hardest one. One more time, please, Drew. So we've got to eliminate it if we can, but that's the hardest thing in the world to do, really. So we're at the next stage. Well, Drew, please. As low as reasonably practical. I think that's where most companies are. Can we get it as low as reasonably practical on that? You know, we want to do this, but this costs money. So we've got to make sure reasonably practical. One more time, please, Drew. So what we say is buy smart on that. Is it the best tool for the job? Is it low in vibration on that? It may be a bit high in vibration, but can I do the job faster? It's looking at the whole process. One more, please, Drew. So buy smart, buy smooth. One more time, please. Now, as an employer, you've got to offer all sorts of information to your people, haven't you? You've got to talk about risks, control measures they can do, but also let them know what your control measures are so they follow them. You know, the reasons why you're doing the job a certain way. Looking at keeping the bodies warm and dry as well if they're working outdoors on that. And it's up to them if they want to smoke, but at the end of the day, smoking does affect circulation, so it is another adding to the risk. One more time, please, Drew. So under the pure regulations, provision of use of work equipment, we've got to make sure all tools are in good condition at all times. Next slide, please, Drew. Now, when we're talking about tools in good condition at all times, do we check? That's the main thing on there. Do we oil tools before we use them if it's a pneumatic tool, things like that? So how we manage risk now, lots of people do, is we come on site and we actually produce a tool register for you of all your tools. We'll go around measuring tools. It might be 100%, it might just be 10%, depending on how many tools you've got. But we create the tool register. What looks something similar to this, where we'll have the unique serial number for the tool, the type, what it was, the make, the model on there. But then we go down the vibration meters per second, the coloured part on there. If you want to click again, Drew, please. From that, we can start seeing where the problem tools are. You know, the ones in red, the ones which are causing us the issue on there. So we could work on those at that point. Is there a better tool for the job on there? It could be using several angle grinders on site. One type of angle grinder gives you less vibration than the other. You know, could we use this as a tool to decide what types of tools we buy in the future? You know, to give us some kind of informed knowledge before. One more, please, Drew. Now, then if we've done the reds, we can start looking at ambers. You know, we can start refining the process, not just being happy at 2.5 meters per second squared. Can we get it lower? And the green ones just take care of themselves, really, don't they? The only thing we have to worry about the green ones, if your vibration's high anyway, we're talking about your total dose in a day of vibration. Another slide, please, Drew. So, and one more. Okay. So, like I say, we can use it for selection. We can use it to say, well, as from now on, when we're looking at those figures on there, that Hitachi Recep saw has given us 13.53. Let's not buy that make and model anymore. Is there another tool out there? And we could put that on the blacklist and tools not to buy. It's just a way of giving a more informed view. One more time, please, Drew. So how other companies do this? They can look through the tool registers. They can make sure there's a repair system, train people on there. We look at, is there a better consumable for the job? You know, do the operators make sure their consumables are sharp? Are they making sure that they let the tool do the job rather than forcing it on there? One more, please, Drew. So when we come to meters per second squared, we can get that data from two areas. We can get it off the manufacturer and we can measure it. If you want to click, please, Drew. So where we can get this data, click, please. So under the regulations, Supply Machinery Act, the employer, the OEM, the people who make the machine, have to tell us what the vibration is on the tools on there. If you want to click again, please, Drew. You've got to ask yourself then, is there any problem using the manufacturer's data? Maybe, maybe not. You can click again, please, Drew. There's some sort of factors here, though, isn't it? And how did they do their test? It was a brand new tool. What were they, say it's a drill, what were they drilling into? Was it a soft piece of wood and you're going to go into a hard bit of concrete? Was it a small drill versus a big drill? No. You've got to make sure these figures are correct when you use them. So if you want to go again, please, Drew. So to cover that, we have a thing called the K factor. And the K factor is an uncertainty figure. So we're going to go again, please, Drew. So the K factor is a tolerance. It can be plus or minus, but generally we always think of it as a plus on there. So that hammer drill's got 11 meters squared, but the K factor is 1.5. So we'd need to add, I'd always add that figure to use my, if I was going to use those as published figures. So please another one do. So we've got here, you've got manufacturer's figure of 6, K factor 2.5. So it could either be 3.5, 6 or 8.5. So one more click, please. So do you want to click through a couple of here and I'll tell you when to start. So they're the figures what we've got there. So there's quite a range of the K factor there. So if you want to go again, please, Drew. So if we're going to work off 6 meters squared, that gives 1 hour 23 minutes of usage on there. So if you want to go again, please. If we're working off adding the K factor in, it's only 42 minutes. So one more click, please. That's 41 minutes difference. So if you're only working on the 6 meters squared, and that operator's going to be using that tool for a period of time, you'd be quite a way out on your figures just using that. So if you're going to use manufacturer's data, always add the K factor onto it on that. Next slide, please, Drew. So we can measure the data as well. That's what we tend to do an awful lot of. Next slide, please. So the difference is we come on your site. We take the readings on your site on there. Next, please. It's using your tools. It's not a brand new tool out of a box or it's been checked. It's on your tools on there. Next slide, please, Drew. We don't operate the tools either. We get your operators to operate them because then it's how they use the tools on there. We're not trying to just put less pressure on there to get a different reading. It's how they use the tools on a daily basis. Next one, please. And it's on your components. So if you're drilling into hard steels or cutting into a different type of wood, it'll be on the products what you're using at that point. So although it's never going to be accurate because one day it's going to change slightly to the next, it's the best we've got. It's measuring data. So next slide, please, Drew. So what we do is we've got, that's quite an old machine there. There's Larson Davis on there. But we strap the accelerometer onto the side of the machine where the hand goes, not where the wrist is or further down the tool. It needs to be where the hand normally is because that's going to give us the figure what's going into the person's palm. Next slide, please, Drew. Now, the Supply Machinery Act also makes it demands of the people who make the tools to actually, the OEMs, to actually try to reduce vibration and noise on a regular basis, and they do. So when we talk about reducing vibration, it gets a little bit easier year on year because the tools are getting better on there. Back in 2005, when we started doing this to 2.5 meters squared, it was almost impossible. Now with some of the tools which are out there, we can get to those figures a lot easier. Next slide, please, Drew. So we're talking about early warning signs. We've got to tell our people who are using these tools what to look out for because we want to catch it early. So early warning signs, what we go for. So next one, please, Drew. So it's that tingling, that numbness in the feelings, not when they're working, it's generally when they get home at night. And it's not just one night, if they're feeling that on a regular basis. And next one, please. It's, you start losing the nerve endings stop being able to tell you if you're picking a screw up off the floor or something like that. They can't quite feel it the way they used to. You know, when they do buttons up on the shirts, it isn't quite the same. And next slide, please. You know, they notice the hands aren't as strong as before on that. Because we're talking about hand-arm vibration. It's the whole arm what's working into this. And next slide, please. Sometimes they will notice that they'll get this white finger on there, especially when the hands are very, very cold. They'll notice a whiter patch than elsewhere on the hands. And next, please, Drew. If they don't do anything about it then, it just gets worse. So next one, please, on there. So next one, please. It's that permanent numbness in the hands. That it just doesn't go away on there. Next one, please. You know, it's not only the pain, the fingers do swell up. Sores appear on the fingers as well. And next slide, please. You know, that continuous aching on there. You know, right up their arm. And next one, please. You know, small objects can be really difficult to pick up at that point. You know, so some people find it very difficult to get dressed in the morning. On there, next one, please. You know, and it's not just on one finger, it's gone down all the fingers now on there. You know, there's no turning this back. Once you've got it, you've got it. Next slide, please. So there's no cure. If you want to click through these, Drew, on there, but it's circulation related and nerve related on here. Things like carpal tunnel we can operate on, or well, surgeons can anyway. You know, there's some things we can do work with, but once your nerves become affected, your circulation's affected, it's very hard for that to be cured. On there, next one, please. So prevention's the best thing. If you want to go again, Drew, go and click through. So we want to keep people below 100 points, but 400 is the maximum anyone's allowed to be exposed to on that. Now, hopefully you got some questions on this, because we've condensed to a half-day course into a very short period. And I'm really sorry it's been a bit sort of sticky asking Drew to actually keep clicking the button on a bit there, because normally it flows a lot easier because of that on there. But hopefully there's something in there. But if you've got any questions, please get in touch or ask them at the end. Drew's going to do a little bit more now.
Lovely, thanks for that, Richard. I hope you all found that insightful. You know, Richard's been dealing within this area, as I said, for an awful long time. As you know, somebody experiences it himself. He's it's very important to him. So us as a business, we operate a framework of different services for all of our customers, our large industry customers, which basically we have the cradle to grave approach. So we deal with the whole process from start to finish, ensuring that you've approved the right tooling, everybody's using the same tools, so there's that consistency. The testing, the training, the management, the maintenance schedules, which obviously maintain the machines for a longer period of time, as well as obviously checking the HAV levels all still the same. So we've many years of experience within this field, and as I said, hopefully you found this useful. We would love to engage with you if you want some additional information. I think there's a Q&A now, Steve. I think that's what we can do. Obviously, Southern Power Tools and myself, Drew Bartlett on LinkedIn, if you would like to, sort of add us on and do some communications with us. We'd love to engage with you. But yes, Steve, how do you find that? And anything from your side?
Yeah, thank you very much, both Drew and Richard, for that. Really interesting. I think it really helps to raise awareness of, the real impact that can have on people's lives, to be honest. So it's really, really good. Thank you for coming along and doing that for us today. We don't currently have any questions registered. I'll give it just 30 seconds just to see if anybody wants to pop any questions in the Q&A chat function, which go ahead and do that if you need to, if you'd like to. So I'll give you 30 seconds to do that. Whilst I'm doing that, what I will do is just mention that you can keep an eye out also for further Crown Commercial Service supply delivered web events, which will go on throughout next year as well. We're planning to hold more on a number of specialised topics. And then I think the next one's focused on collaborative innovation in construction, so that should be quite interesting. If you go to cronecommercial.gov.uk/events, you'll see the events that we have planned in there. This has been recorded today, so you will get a link to the CCS YouTube channel, link for the webinar that's been conducted today. So I'll just give it another sort of 10-15 seconds, see if anybody's got any questions. If you have, put them in the chat now. Okay, so we've got a couple of questions. So we've got one here, which is, what's the HSE's thoughts about using the K factor rather than the measurement of the tool?
Shall I answer that one?
Yeah, if you can, Richard, that'd be great.
Chip in, yeah.
I can't talk for the HSE. The K factor's there for a reason, because there's such an uncertainty. So I wouldn't say that any manufacturer of the tool deliberately misleads us on their figures, but there's only so many tests they can do. So the HSE have demanded that figure goes in there, but it still could be a long way out on there. At the very least, add the K factor onto your data on there. I can't answer what the HSE's view are there, so sorry about that on there.
That's what we would always do whenever we supply tooling, you know, for our contracted customers. Before the equipment leaves here, it is all tagged with usage times, color coded, traffic light system labeling, so that it's a very clear indication to the user what they're dealing with. And we would always include that K factor, because you always have to look at worst case scenario. So yeah, I'll back that up, Richard. Yeah,
what I would say,
what you're doing.
and so what I would say is, it's very difficult to get the K factor off some manufacturers. You know, they have to publish it, but it might not be in the same position on their web page as the actual vibration on there, because they maybe don't want you to add it on there. But it's well worth trying to find it out on there.
Yeah, I think you know, from a legal point of view, that needs to be in there somewhere. But that's what we do. We take all of that headache away. So we deal with that for you. So you know that if when machinery is delivered, it's already tagged up with exactly what, you know, the correct information.
Which is one of the things actually we didn't discuss, was tool tagging at that point on that. The traffic light system basically means that if your tool's got tagged on, it informs the operator at point of use what the vibration figures are. But if it's in a traffic light system, if he sees the red, he's often more cautious than he sees a green tag on there. And so we'd always recommend having tags onto the tools.
Okay, thanks. So there's another question. So what sort of things does the uncertainty K value cover? Is it different drill bits, etc., or just variation in tool?
It really is not that specific. It's just because they could be doing it different ways. You know, there's some manufacturers could just be an air test for what we know, just running it in air. It's just a figure what they put in there. It's not a very scientifically figured they've come out with on there. So it could be relatively low. If say they're using a drill which is 3 millimeters, that's going to be completely different to a drill with, say, 18 millimeters on there, the contact area on there. So I personally don't know, because I wouldn't like to invent anything. I personally don't know how to calculate that figure, quite honestly, on that.
What we do when we do the physical testing in field testing, we'll always do 3 tests, because the magnitude does change. It's very sensitive. So we will always operate a 3 test rule, and then we take an average over those 3 tests, and that is what we will label the machine with. So that's when we do our testing. And then obviously, because that's true value, we don't use a K factor within that.
Okay, thank you. There's no further questions at the moment. And yes, there is. There's another one that's just arrived. Okay, so it's the variation based on the data set measured by applying one standard deviation. That's actually more of a comment than a question by the sounds. So thank you for the person that's included that in there.
Yeah.
Okay, just give another 10 15 seconds to see if anybody else wanted to raise any further questions. Please go ahead and put them in the Q&A chat and we can get those answered for you.
If anybody has got any questions, what they think of later, if they just email Drew, there'll be an email address on the Southern Power Tools site, or Steve as well on there. We can answer anything.
Absolutely, yeah. Our website, southernpowertools.co.uk. Obviously, all of our contact details are on there. Be more than happy to chat with you through there as well.
Brilliant, thank you. Okay, so I don't think we've got any further questions that have come through. So we'll close it there. So thanks everybody for attending today. I hope you got something from it and there was some value you took from the day, from the webinar. Thanks again, Drew and Richard. Really appreciate you coming along and delivering the webinar for us from Southern Power Tools. I hope to see you again soon. Thank you, everybody. I'll now conclude the webinar and enjoy the rest of your day.
Thank you very much all. Have a very good Christmas. Enjoy your breaks.
Thank you, everybody.
Okay, goodbye.